My name is Ifigenia. I'm a psychology graduate, and today I'll be talking to you about monkeys, language, and babies, and how they come together under the term of perceptual narrowing. So perceptual narrowing is the hypothesis that the ability to tell the difference between familiar or native and unfamiliar or non-native stimuli decreases within the first year of life depending on environmental exposure. So what that basically means is that when you're younger, you can tell the difference between different things in your environment, but as you get older, you lose this ability. So stimuli can be anything in your environment, and today we're going to look at faces in terms of faces from different races and also faces from different species, and then we're going to also look at sound in terms of language. So let's have a look. First, we're going to look at faces. So what if I told you that infants, so that would be babies up to 1 year old, are better than adults at recognizing faces? This is probably how you would look at me. So adults experience the other race effect, which is also known as the own race bias. That means that people are more accurate and quicker at recognizing faces from their own race as opposed to faces from different races. So this is an effect that's been widely studied, but as communities become more and more diverse, it's likely to decrease because we become more familiar with faces from more cultures. So we're more likely to have more practice with them at the end of the day without having to think about it too much. So importantly, this effect depends on our environment, our experience, and the faces that we're used to. So first, participants are presented with faces, and then they're presented with two more versions of that face, and they're asked to say which face it is that they've seen before. So adults can do this. They can say, yes, this is the face I've seen before, but as you can imagine, babies cannot speak and say that. So instead, what we do is a method called habituation. So what happens is that we make the babies stare at this face for a while, as long as it takes for them to get bored at it. So then when they see the face again, instead of staring it again, they look at the new face because they're not bored at that face yet. So this whole process is called habituation, and it's how we know that babies recognize that face because they would rather look at the new face, which is more interesting than the one that they've already seen. So what we see from studies with adults is that adults are quicker and more accurate at recognizing faces by this method when they're presented with pictures of faces that match their own race. However, at 3 months old, babies are equally good at recognizing both familiar and unfamiliar faces. So both faces from their own culture, from their own race that they're used to looking at, and both faces from other cultures. However, again, at 6 to 9 months, this ability declines, and like adults, infants can no longer do that. They become quicker and more accurate when presented with pictures of faces from their own race as opposed to a different race, which is, as we've said before, the own race effect or the other race bias. Now, what if I told you that when you were a baby, you could recognize monkey faces? So by doing the exact same procedure, by showing faces one at a time and seeing whether the baby stared at the new face or not, they could also tell that babies were just as quick recognizing faces from humans as they were at recognizing faces from monkeys. Even more surprisingly, they could do that with sheep as well. This was surprising because sheep are not primate animals, So they're thought to be from a different family. So we know that maybe it's not just revolutionary to recognize faces from other primates, but it's just a mechanism that would work with anything. So similar to before, we see how during the familiarization period, the babies were shown with two faces, and then in the test period, one of these faces is the same, and I'm going to have difficulty telling you which one it is, but one of them is the same, and then the other one changes. And so you would expect, here for example, I can see that these two are the same. The baby would have already been familiar with this face, so it wouldn't have looked at this one. Instead, it would have looked at this one. So that's how we would know that it recognized this. So let's have a look at the results. Indeed, we can see that at 4 to 6 months old, babies had a better, higher mean time of looking at the novel face, so the one that they hadn't seen before. But then at 9 to 11 months old, this just dropped dramatically, and then adults are even worse at this, much worse at this. So now we've talked about faces, let's have a look at sound and how this works with sound. What if I told you that babies can hear better than you? Well, perhaps this may be worrying, but not surprising, because when at birth, our hearing is actually the best it will ever be. But that's not the same for our eyesight, because our eyesight is pretty bad when we're born, and then it gradually gets better. But babies can hear better than anyone. There's two different types of perceptions we should talk about before moving into how perceptual narrowing fits with all of this. So continuous perception is when variables are on a continuum. So we can tell the difference between being 1.88 meters as opposed to 1.63. And you can have any of these values, and that absolutely makes sense. However, we also have categorical perception. So for example, for colors, if I ask you what color this is, you can tell me it's red, it's green, it's blue, but it's going to be a lot more difficult for you to tell me the in between of those colors. But at the same time, we know that there's turquoise, for example, but would you be confident that you know about every single color variant by name? So we talk about sound in terms of phonemes. Phonemes are the smallest sound unit that carries differences between one meaning and another. So we can have b, and we can also have p. Phoneme boundaries are where the physical parameters, such as voice onset time, changes perception from one phoneme, b, to the other, p. So now we have this useful picture here to help us along with an example. So we know that a 20 millisecond difference across the phoneme boundary, so over here, is difficult to distinguish. So you can't easily tell apart when I say ba or pa. Like when I would show you something that's yellow and something that's red, you would be able to easily tell the difference. But a 20 millisecond difference within the phoneme category, so from over here at the beginning, over here, is hard to distinguish. Imagine looking at denim blue and ocean blue. It's very hard to tell the difference apart these two. And the same happens with sound. But newborn babies have the potential to make any phonetic discrimination because they have continuous perception of sound. So these differences within the phoneme categories are not hard to distinguish for babies. Instead, babies are universal listeners, so they can hear all of those phonetic discriminations, but this stops at about 9 to 10 months old, and the ability is lost. So let's have a look at how researchers look at perceptual narrowing in terms of language.
6-month-old Matthew sits on his mother's lap. A researcher sits opposite and keeps his attention on a colorful toy while a tape plays two sounds. One is ba and the other is da. a sound only used in Hindi and one which most English-speaking listeners can't distinguish from the English sound da. During the initial training period, a toy bunny is lit up in a large glass box to the side of Matthew the instant the da sound is played. When the ba sound is played, the bunny stops and Matthew turns back to the researcher. The routine continues until Matthew learns to associate the change from ba to da with the bunny. Matthew even turns his head in anticipation when the researchers delay the bunny's appearance. Matthew is now ready for the test phase of the experiment. A new tape is played, this time with two different da sounds that are only used in Hindi. Even though they are two completely different sounds, an adult who can't speak Hindi doesn't hear the difference. But Matthew immediately turns his head towards the bunny when he hears the change from one Hindi da to the other. Although he has never heard Hindi spoken, researchers recognize that at 6 months, he is still the universal listener, able to distinguish all sounds. Emma, who is 4 months older than Matthew, has come to the lab for the first time. After a similar training routine as Matthew, she's presented with the same problem of distinguishing the two different Hindi da sounds. But at this age, Emma, whose parents speak only English, doesn't react when there is a change from one to the other. She is more interested in the toy in front of her than the bunny. This leads the researchers to conclude that by 10 months, the baby human stops being the universal listener and, like the adult of the species, no longer hears the difference between the two sounds.
So now we've seen how researchers look at the perceptual narrowing with the conditioned head-turn paradigm for Hindi. Let's have another look about how this works for Japanese.
I'll show you the differences. Please listen carefully. English R sound is ra and English L sound is la. Japanese R sound is la.
So personally, all I hear is ra, la, and then la. So this is confirmation that I'm not an infant and that there's differences indeed in the way that Japanese is spoken. So let's have a look at studies that have looked at Japanese then. So when looking at discriminating, telling the difference apart A and L for Japanese infants and for American infants, we see that at 6 months, the percentage correct for telling the difference apart between A and L with the methodology that we've seen before with the conditioned head-turn paradigm with that nice toy that lights up. We see that Japanese and American infants are doing just as well as each other. However, at 10 to 12 months, Japanese infants are starting to do worse because there's no distinct difference between these. But then American infants are doing better. So we see that this ability to tell apart is getting lost when you don't have it in the language, but when it is part of the language, it just gets better. So based on these findings, why do you think perceptual narrowing happens? Take a minute to think about this. So based on these findings, we can infer that because American infants became better at discriminating R and L within their own languages, we can tell that they focus on learning a specific language. So it's kind of a mechanism in terms of use it or lose it, because you keep training on what is in your environment, because that's what you need to know in order to survive. So this is why perceptual narrowing happens. You're spending your resources where they need to be spent. And do you think we can stop perceptual narrowing? Take a second to think about this as well. So let's have another look at our definition of perceptual narrowing. Perceptual narrowing was the hypothesis that the ability to tell apart between familiar and unfamiliar stimuli decreases within the first year of life, depending on environmental exposure. So what this tells us is that if we keep being exposed to those unfamiliar stimuli, then they're no longer unfamiliar. So we can't really stop perceptual narrowing. An example of when this happens is for bilingual people who are exposed to 2 languages at the same time. So if someone was to be exposed to Japanese and English at the same time, then they wouldn't have a problem distinguishing between R and L at all. So this study looked at this specifically. Let's have a look. These are the typical findings that they found, that at 10 to 12 months old, English infants had lost the ability to distinguish between differences in Japanese sounds. Here we have a more specific study looking at only American infants, and we can see that those who were exposed to English only, their performance also decreased. However, those who were exposed to Chinese in the laboratory, their performance remained pretty much stable. It didn't change. So because they were still exposed to Chinese, there was no difference in their ability to tell the difference between the sounds. Now, what's important to note is that this exposure was social, and it was between a Chinese speaker and the baby face to face in the laboratory. The other interesting thing that this study found was that when the baby was exposed to auditory stimuli, so that could have been a CD of Chinese language or a video of Chinese language, then performance still dropped. So there's something about this social interaction that we have with babies that allows them to learn from us, which is amazing, I think. So let's have a look at what we learned. We come to this world with our brains equipped to adapt to any possible scenario, able to adapt to any environment. So we're coming in this world able to learn any language, we can detect any face, any sound, which means that, technically speaking, Tarzan's story, who lived and spoke to monkeys, could have a true basis. The other thing we've learned is that babies can tell the difference between familiar and unfamiliar stimuli, including faces across different species, across different cultures, and sounds across different languages. However, this ability is lost unless the stimuli remain as part of the environment. So unless the babies keep hearing different sounds and keep looking at different faces. These are the studies I've talked about. These are my references. Thank you so much for listening.